Welcome back from spring break as we now return with the second half of this course. I want to remind you that the Discord bot, specifically the stat bot, watches how often you communicate in Discord. That will be used to award points at the end of the semester in the class. So if you are a Cabrillo student and you haven't been chatting often, you won't be getting as much points. So let's get started. The picture of the week. I wholeheartedly agree with this. This time, the topic is client security. You know, our user remains the weakest link. And to that end, we must raise the level of security on the devices that the users interact with the most. Because time and time again, we educate our users to be safe, but it doesn't always work. So maybe we shouldn't put the burden on that user to be secure all the time. Maybe we should complement them with secure technology. Starting with things like secure boot. Bypassing security when desktops had a BIOS chip was easy. All you had to do was overwrite the chip, or if you could open up the box, be able to change the jumper and the password is removed. Piece of cake. With UEFI, we have secure boot. UEFI also has the hardware root of trust, which verifies the physical hardware. If the physical hardware is changed, then the system just simply doesn't boot. This is just one simple way that is already available on most systems that you can implement. If you ever thought further of electromagnetic spying, such as knowing the keystrokes by picking up signals with an antenna, or transmitting data from an air-gapped machine through the power supply is science fiction, it's a fact. It is totally possible to do those things. I have articles in the lecture notes to help you see those things in action. The other thing that you need to be aware of is supply chain infections like those seen with SolarWinds. If an attacker wishes to get into devices, and a way, like with SolarWinds, would be to infect the devices, parts, or software that are coming into your network from anything from motherboards, USBs, frames, and applications. If done correctly, like SolarWinds was for a number of months, they'll be hard to detect and expensive to get rid of. Now, there are a variety of operating systems, not just desktop and server. You have the network operating systems, such as Cisco's iOS or Juniper's JuneOS. You have appliances. You have kiosks, and also mobile to keep in mind. Now, with all of these, you also have to keep in mind to, that's the button I wanted. You have to keep in mind to disable unnecessary ports and services. Very simply, if you don't need it, turn it off. This can be a background or a startup program to a service. For example, why would a laptop share folders? The laptop is a mobile device. It shouldn't be sharing folders. That's the job of a server. Disabling default accounts and passwords. This is common knowledge, but not so commonly applied. Time and time again, we have seen devices that have common username and passwords that are publicly known, and people don't change those passwords. They just leave it as is, and then get breached and wonder why. Employ the least functionality. The system should be set up only to do what its intended purpose is and nothing more. Super annoying for users, but this is a way to ensure security. And create application black and white listing to say what applications are pre-approved to run on systems and everything else is not. It's another way of providing a layer of defense to our users who may get tricked by a Trojan, may get tricked by a phishing attempt to run something they shouldn't. Because again, we cannot just expect our end users to be secure all the time and do what's right all the time. That's just not realistic. We would love it, but it's just not realistic. We can continue to educate them, but we should also secure the technology that they use. Patch management has always been something that is mentioned, that you should always update your systems, always install the latest patches, stay up to date. The thing is, patches are not always foolproof. They should always be tested. Here is a case in point from the last decade. We're following the basic premise of if there's an update, install it. Isn't a good idea.
Welcome back. An antivirus program for PCs goes berserk, you might say, unleashing computer chaos across the country. Security company McAfee says a software update caused its antivirus program to misread a non-threatening file. The mistake caused PCs to reboot over and over again, never fully turning on. The problem even impacted operations at hospital in Rhode Island, police department in Kentucky. And joining me live is Pete Juvenile, Systems Administrator for the College of Business at Illinois State University. And Pete, I understand you had problems as well.
We did. It was a very busy day yesterday.
So what happened? Tell me how it affected your system.
Oh, sure. Around about 9 o'clock, we had our first person give us a call that said their computer had just locked up and completely was unusable. And by the time I'd gotten up there, about 3 or 4 other machines had the same problem, and then it just kind of spiraled out of control there.
You're the systems administrator, so I imagine the people are looking at you to solve the problem. Right. And you're as baffled as anyone else on this one.
Well, we originally thought it was a virus up until the point about midway through the morning. We had discovered that McAfee had been causing this problem all along. And what's interesting was it was literally minutes before our 300-seat computer lab was going to check into the McAfee server to download the update.
And McAfee,
and so
they issued a statement saying that we sincerely apologize for the inconvenience this has caused our customers. How many people potentially did you see affected by this yesterday?
Well, it's hard to say because a lot of our people come in at various points throughout the day. Even today, we're seeing individuals come in and report this issue. So we had 3 or 4 classrooms full of students that weren't able to do a class in our college alone. And so we had to address those issues fairly quickly.
Now, McAfee now has a replacement update for people or users to download. Did you do that?
We did. McAfee was really on top of it. It was probably 2 hours before the next app file would come out, and I was just sitting there hitting refresh on the computer screen waiting for it.
Well, they say that they are apologizing again for this, and they've got this, as you pointed out, replacement update for people. So look out for that if you're one of the many thousands affected by this one. Thank you very much. We greatly appreciate it, Pete. Thank you.
Thank you.
Absolutely. Well, minutes from now, President Obama is expected to tell Wall Street how he wants to...
All of that to say, don't just trust updates blatantly. Always test and confirm before you deploy out to your production, including antivirus or anti-malware types of updates. That's not to also say that antivirus is useless. It is definitely useful. But don't just ignore those as part of your overall defense. The easiest policy when it comes to peripheral devices is to deny all. That is a very simple way to just block out all devices. And one easy way of making the network safe is saying no external device can be connected. But that's not necessarily feasible, since many things like SD cards, external storage, multifunctional devices, USB, a lot of USB devices, they require an external connection. So don't just walk into a business and say, we're going to prevent any device from connecting via USB, because that may not be the wisest decision. Always look at the infrastructure, look at what is being used, and create a policy that best fits how we're going to handle peripherals. Now that's the computer itself, devices around that computer. Now let's talk physical security. To me, I believe physical security and digital security are one and the same and should be treated as the same. Just like having firewalls at the perimeter to block out unnecessary traffic or malicious traffic, there should also be things like fences with proper signage and lighting. These are passive barriers to restrict unwanted individuals or vehicles from entering a secured area. We can use certain fenced areas to be used as waiting stations until a visitor is approved for entry. We can have barricades to block the passage of traffic. Things like bollards to prevent any vehicle from ramming into a secured area. Closed circuit television systems, CCTV, can be added to keep surveillance and a record of the individuals in a physical space, while monitoring detection sensors can trigger alarms to guards about a possible intruder. In comparison, human security guards are considered active security elements since they can make split-second decisions and take appropriate action. Applying the layered approach to security, our external perimeter defenses are similar to routers, firewalls, load balancers. Should an intruder make it past those, we need to have other measures to internally protect ourselves, like screener privacy filters that allow only viewing from a direct angle. Various door locks can be utilized throughout a building. This one is a cipher lock. Having access logs to keep a physical account of who has entered a secured area. Using man traps to separate a non-secure from a secured area. Using protected distribution systems to prevent any transmitted data from leaking out. Having things like cable locks as well to prevent devices from getting legs and running away. Switching gears from the machine and securing the machine in and of itself, securing the perimeter of a building, and having some internal defenses, let's look at applications. Since creating applications is the bread and butter of many organizations. Poor coding techniques can create vulnerabilities in applications that attackers can then exploit. Though this test is not coding focused, Security Plus, an understanding of the concepts will be sufficient to pass the questions in this area. You have the development cycles. Developing an application occurs in steps of development, testing, staging, and production. Two application development cycles you should be aware of are the waterfall and its successor, agile models. Waterfall dictates once a stage is complete, the next stage can continue without any means to go back to a prior step, should a mistake arise. Agile does not work incrementally like waterfall, and instead follows an incremental approach. DevOps and secure DevOps fall into this criteria with topics like secure automation, continuous integration, immutable systems, infrastructure as code, baselining, change management, provisioning, and deprovisioning. Sadly, most DevOps teams do not employ secure coding measures. Hence why a lot of our code, a lot of the applications that we use in day-to-day life are vulnerable because they're not built with security in mind. Here are some best practices that are mentioned in the Security Plus exam that should be followed. Proper error handling, taking correct steps when errors occurred so that applications do not abort unexpectedly. Have proper input validation, something that you've seen with SQLi. Normalization, organize data within a database to minimize redundancy. Again, SQLi. Stored procedure, having a subroutine available to applications that access relational databases. Code signing, having a digitally signed applications. Obfuscation and camouflaged code, write an app in a way that its inner functionality is difficult for an outsider to understand and or be able to reverse. Dead code, sections of applications that executes but have no meaningful function. Server and client-side execution and validation. Input validation by either server or the client side. Code reuse of third-party libraries and SDKs. Using existing software and applications or a set of tools to write applications. And with that, we also have code testing. In order to test the quality and security of codes, there are some methods that are outlined in the Security Plus exam, like model verification, test to ensure projected app meets all specifications at that point. Compiled code testing, search for errors that could prevent the application from properly compiling from source. Runtime code testing, testing the code in a sandbox. Static program analyzers to examine the software without actually running it. Fuzzing, deliberately providing invalid, unexpected, or random data as inputs to see what errors are trapped. Stress test, put an application under heavy load to determine if the program is robust and can perform all error handling correctly. And having integrity measures, applications running a set known of approved executables. Any questions on the topics covered today? Okay, seeing none, I'll stop the recording.